Hey guys, today I'll be teaching you how to create detours and function hooks in C or C++. This is commonly used in hotpatching live software or hacking. Please do not use any of the knowledge provided for any malicious activity. So let's get started. I've created this project in Visual Studio. It's just basic console application in C or C++. And to get started, we will create a function called foo, and when we call that function, instead of actually calling foo, it will call bar instead. So let's get that sorted. So first we'll come down here, create a function called foo, and we'll print that. And we'll also create a function called bar, and we'll also print that too. And now if we call foo, it will call foo. So this will call foo when we call it. And now we're going to change it. We're going to hotpatch or detour foo. So when we call foo, instead of actually calling foo, it calls bar. And to do that, we need to create a detour, aka function hook. And how this works is we'll pretty much be editing the signatures to jump to our detoured function instead of where it's supposed to go. So to get started, we'll make a function called void detour, and we'll allow a void pointer. So we'll pass a function into this, and we'll call this source address. So this is where foo will go, and we'll go void target address, and that's where bar will go. So this is the function that will edit this function to instead go from foo to bar. And we will we'll also need to change the memory to allow us to write to the memory location, because in newer operating systems they've added something called data execution prevention, and that's to try and prevent malicious activity like buffer overruns and software exploits. So we'll have to turn that off in our function, but I think it was Windows Vista or Windows 7 and above they added that. So we'll turn it off since we're on Windows 10. Old protection for that. We'll also need to include windows.h. So dword is we can pretty much use a integer in its place. So we're also doing this on a 32-bit process. We can also do it on a 64-bit process, but when you're editing the memory of a program in 64-bit process, it's different to a 86-bit process. So or 32-bit process. So we will change the source to source address, and we can replace these chars with bytes if we want, and we can replace a D word with int. It doesn't make any difference. Target address. And now we will have to find, because we'll be doing a relative jump, we're going to have to find the offset of these two functions, and each function normally, while more related to DLL methods, each function has about five bytes of padding that can be used, and we can use that to position a jump in that DLL function to another location. So if you wanted to hook, say, connect or send or receive in WinSock 32, well, you can just edit that little the 5 bytes of padding and jump it to your new function where you can play around with the data and pretty much do whatever you want. So that's normally used quite a lot in game hacking, and I guess and creating cracks for software and everything. Yeah, so I don't recommend you use it for that, but that's what a lot of people do use it for. And now we'll create an offset of the two addresses. Target source. Well, now this is where we're going to have to use virtual protect, and we need to make it so we can edit the source address. So I think actually these methods here are different. These are different to the DLL methods you would call. So if I call this, I'm doing pretty much a relative jump to another jump call that does a jump to the exact function. So we're editing the jump's jump. But if this was a DLL call, it would have the 5 bytes of padding that we would edit and then jump to our own method, and then we can do some editing there and then return back to the patched function and continue our data flow through that. So it's page execute. See, this would normally be just write. Oh, just read. Sorry, this attribute would normally just be read for that I guess that memory location. So we're making it executable, readable, and writable. Well, it'll actually be readable and executable. Sorry, normally the source. And old protection is pretty much just saying that it will get the old memory protection and store it in here, so we can quickly swap it out later on to restore it back to normal. And I'll do that so you can see what it's like. So we've got the source, we've got the target, we've got the offset, and now we'll start have to edit these memory allocations. So we go char, we go source equals 0 times E9. E9 is the opcode for relative jump. So you can if you want to find all these opcodes, you can either right click and view the disassembly of the our program, or you can either do that, or you can go to the Intel site and download the instruction set manual and look at them through there. So I highly recommend you go for a read over that, especially if you want to do some low-level programming. We'll go int source +1. So the first one's the jump that we're doing, so the relative jump. This one is where we're going to store the address. So the address offset pretty much. So this offset is going to go to our bar function, and then we'll restore the previous memory protection. So we'll just go all protect, and that should be it. And then we can go detour foo bar, and watch this. Now if we call foo, it's not going to print foo, it's going to print bar instead, and that's because of our detour method. So let's run that. See bar, so that's working correctly. And I'll show you if I turn this virtual protect off, you'll see that we can't actually edit that data, so it'll error out for us. Yeah, write access violation. So we need to add virtual protect so we can actually edit that memory location. And then we could add another method called tar, foo bar tar, and we'll go from bar to tar. So now it's going to detour foo to bar and bar to tar, so foo's going to call tar. There we go. So I hope you learnt something new here, and I'll also put a link to the source file on GitHub if you want to have a play around with it and see how it works, and leave in the comments if you want me to show you anything else low level, if you want me to do a detour hook on a DLL function, and I'll also write that up because it's a little bit different here. You need to get the address, you need to use different Win API functions to get the address of the DLL function, and some other little specific things. So just leave me a comment if you want me to show you that, and thank you very much for watching.